All right, good afternoon, everybody. My name's Derek Abbott. I'm here to talk a little bit about electrical engineering and why that is a cool pathway ahead into the future. But before I start about specifically talking about electrical engineering, let's just talk about engineering in general. What is actually engineering? What distinguishes it from the fundamental sciences? And basically, it uses the fundamental sciences, it builds upon those. So if you like science, you'll also like engineering, but it goes a step further. It takes those sciences and does a process of optimization. And that is why industry loves engineers, because we can optimize things and make things work and make working things for industry. Let's take a quick look at, say, engineers versus science. At least when I was just came out of high school when I was a kid, I loved things like maths and physics. There doesn't seem to be a course called engineering in high school, but those were the two subjects I loved. And I assume because you're in the theatre here, you also like those two subjects. And it was a very easy thing as a high school kid to say, look up to somebody like Einstein, because I liked physics, and say, aha, physicist. But there never was quite a picture to put on this side for an engineer. Like, does anyone know who the most famous engineer in the world is? You all know that Einstein is the most famous engineer. So there wasn't a role model like that to easily look up to. So it was a difficult choice when I was at high school to know what to do. And of course, the most famous engineer in the world is Mr. Bean, because you may or may not know that the actor Rowan Atkinson actually did a master's degree in electrical and electronic engineering at Oxford. So he's very well educated, probably better than me. And yes, but the surprising thing is, why should the physicists claim Einstein? When you look at Einstein's history, he actually came from an engineering family, and people don't realize that he had all these engineering patents for making fridges. He did that on the side. So in a sense, he is a good example of an engineer on one hand. So maybe we should claim him as well. So what we're going to do with you at the end of the day, by the time you've done your degree in engineering, is hopefully you'll be some morphed combination of the two. Now, engineers use mathematics. So if at high school you liked physics, you'll also like engineering, as I've pointed out. But if you also liked maths, you will like engineering, because engineering builds on mathematics, uses mathematics for its optimization process. But the great thing about the type of maths we do in engineering is it's not the kind of pie-in-the-sky maths that is kind of intractable. It is useful, tractable mathematics that you can get your head around. So if you liked mathematics, this is an area to get into. So now specifically to electrical engineering, electrical and electronic engineering. So it's a funny degree name because it's the only degree where there's kind of like two things with an and in it. Usually everything is just one thing. So what's the distinction between these two things? Basically, in a nutshell, electrical is anything that's high voltage and electronic is low voltage, just put it very simply. And what we'll teach you in this degree are the fundamentals that could help you to go either way in your career, depending on what you're interested in. So it keeps you very broad. But there's more to it than that. It turns out that electrical and electronic engineers also have to deal with photons, not just electrons. Like we have to interface to displays, to display things with light. We have to go down fiber optic cables to send information. We also have to deal with the informatics of information, how to store and manage vast amounts of terabytes of information. We have to process signals, the maths behind that, and we're also very good at software as well. So it's an amazingly broad degree that encompasses so many things. And because of that breadth, industry really loves us. And if you look roughly at the different salaries here, you can see electrical engineers are in the top band when you compare with other engineers. So a little bit about my own story. Well, when I was your age, that is actually a photograph of the floor on my bedroom. I've actually cropped out the embarrassing parts. This is just a little bit. But as you can see, I was interested in science. These are science textbooks here. That's a sock, because I was just a normal messy kid like everyone else. And this was a circular slide rule. And that is a pocket calculator back then. That was actually one of the very first pocket calculators in the world. I bought it when I was 14. Cost something ridiculous like $400. I spent a whole year earning money delivering newspapers to buy it. I was that excited to have a calculator. And I guess this is one of the things that that really inspired me to get into electronics, the fact that you can have these gadgets that can change the world, that can do fantastic things. Because before then, I really suffered with these slide rules. I hated them. And to be able to just punch numbers in was fantastic. So, but to be honest with you, I didn't really know which subject to choose when I just came straight out of high school. I ended up choosing an electronic profession in the end. But why did I do that? It's kind of a process of elimination. As I said, I liked maths and physics the most. But I just didn't want to do maths all on its own. It just seemed too restrictive. I wanted to connect to the real world more. Biology, medicine, and chemistry, you know, to be honest, I had a terrible memory. I couldn't remember all those long words and chemical symbols and stuff like that. Physics, I said I liked. Mechanical engineering, you know, that's, again, a bit restrictive. That's kind of moving parts and engines and things. All my Meccano constructions never worked. You know, I wasn't very good at that. Civil engineering, buildings, blocks of concrete, again, very narrow. So I eventually ended up going for the breadth of electrical and electronic engineering because, you know, you see so many gadgets around the world. Everything is electronic these days. So why is it cool to do electrical and electronic engineering? Well, here's an interesting thing. If you look at, say, each type of different kind of engineering, like civil engineering, you're like in the building industry. Mechanical industry, you're in the industry of machines and things like that. And say chemical engineering, you're in the chemical industry. But what industry are you in if you're in electrical engineering? You're in actually all the industries because you can get a job anywhere because all the industries require electrical and electronic engineers. All the industries use electronic gadgets and instrumentation. And so this is the bottom line, that electrical and electronic engineering has great breadth. It spans so many things, and basically if you go in that direction, the whole world is in your hand. It opens many doors. Another reason why electrical engineering is cool, why it's cooler than all the other forms of engineering, is it's the form of engineering that really sets the pace of technology. It's the form of engineering that's right at the cutting edge, right at the front, that changes our lives, changes the way you do everything. Like, you just got to kind of look at the internet and smartphones and computers and all the developments that have happened in your own lifetimes and see how the whole world has changed. It's always electrical and electronic engineering that's cutting that edge. And so as a future career, you want to be at that edge for two reasons. One, because you don't want to be dragging behind, always being behind everything. You want to be in the front. And you also want to be able to easily adapt to all the changes that are happening around you in your career. Because people's careers these days sometimes change every 5 years because everything's moving so fast. So it's better to actually be in the industry that's creating the change in the first place so you can keep up with it. This is just a funny movie with Danny DeVito. I don't know if you heard of it, but one of the things he said, funny one-line quip, is he says, the surest way to go broke is to keep an increasing share of a shrinking market. So by going for electrical engineering, you're always going into an expanding market. You're always at the edge that's expanding out and changing things. So that's a key thing you should be looking for when choosing your subject. Of course, my philosophy is choose the subject that you're most passionate about. Always go with your passion. Don't do electrical engineering just because you think it's going to give you lots of money. Do it because you really want to. If you really like chemicals, go for chemical engineering. Don't let me sway you from that. But if you're at that stage where you kind of like physics, you like maths, but want to do something really interesting with it and stay at the cutting edge, then electrical engineering is for you. So what are all the various different things electrical engineers do? I'll just give you a very fast tour. Obviously, electricity has to come from somewhere and it has to be distributed, and we have to power the planet. And that's what electrical engineers do. If you look around your homes, you have electrical devices and gadgets all over your home, and who makes those? Electronic engineers. Your car, your modern day car is full of electronic sensors and meters and gadgets. That's what electronic engineers do. They make those things and design those things. In the aerospace industry, all those electronic controls have to be designed by electronic engineers. Here's another interesting aerospace example. This is called a laser gyroscope. As you can see, it's a bunch of electronics with a laser beam that whizzes around, and it can tell the direction an aircraft is rotating in. And so it's used in the inertial guidance systems of aircraft and aerospace vehicles. And it replaces the old-fashioned mechanical gyroscope, and this has no moving parts. And so you see, this is another illustration. The things engineers do are actually putting mechanical engineers out of business, because we can do things solid state. Talking about aerospace, that's another huge area where electrical and electronic engineers are involved in. For example, satellite systems, absolutely chockers full of electronics, and it's us guys that design that stuff. And as you know, satellites are vitally important for remote sensing of the planet, for telecommunications. All our phone calls are routed through them. Also for GPS systems, for knowing where you are on your GPS system that's in your car that shows you where you're going. That GPS system has totally changed my life. Before I had a GPS in my car, I remember I used to keep taking wrong turns and getting lost. Just think of all that petrol I wasted. But now I can go directly the most efficient route and not miss a turn. Of course, the other thing, this is a cute photo of Bill Gates when he was young, but the other thing that electrical engineers do is, of course, they're the driving force behind computers and the hardware that's in those computers. And so the computer revolution is due to us as well. And underpinning those computers, of course, is the microchip. And this is an example of a microchip designed by electronic engineers. Electronic engineers also at the forefront of the wireless revolution, smart cards, smartphones, Wi-Fi, all that sort of thing. This is what electrical and electronic engineers do. The other, talking about an expanding market as opposed to a shrinking market, what we could see happening in the future is more and more need for sustainable energy, sustainable electricity. You will realize, without me having to preach to you, that oil is a shrinking market. It's going to be shrinking more and more. And so we're going to need more and more engineers to do this sort of thing, like solar and wind power. So that's a big issue for the future. Also, you've only got to look around the medical world and hospitals to see the impact electrical and electronic engineers are making. For example, implants that go into the human body, like this cochlear implant, this is something an electronic engineer has to design. And look at all the medical equipment that you get in hospitals. This all has to come from somewhere, and we design that stuff. When you look at the internet, the vast internet spanning the world, the data that flows, you have things like electronic banking, e-finance, things that you need to keep secure. Electronic engineers are the key people that know the mix of both software and interfacing to the hardware and can ensure the security of data. And another aspect of electronic engineering is investigation, detective work. So there's some examples here, like forensics. There's a lot of electronic equipment involved in that. There's mining of data, vast, huge amounts of data that need to be investigated and get the information out of it. And there's also the investigation in the sense of research and doing the latest things in electronics. And this is just one example I put here for fun, is plastic bendable electronics is going to be the next big thing over the next few decades. And so these are the things that engineers are investigating and researching. So electrical engineering has all these different interesting aspects. Also, stock markets are fundamentally all wired up with electronic instrumentation, and also increasing numbers of electronic engineers, because of their great math skills, are being used to do maths around that and mine that information and help economists to make the right risk assessments and decisions to make money on the stock market. So here are all the points that I've been making where electronic engineering contributes to powering, enabling, connecting, sustaining, and investigating. So all those 5 things. And if you think about all the other forms of engineering, like, you know, civil engineering, mechanical, chemical, they do some of those things, but none of them does the connecting aspect. This is where electronic and electrical comes in. It connects the world together. It connects people through wireless communications and the internet, etc. So if your passion is, you know, chemicals, you know, go for chemical engineering. If your passion is for mechanical things, go for mechanical engineering. But if you have a passion for keeping that sort of breadth, keeping at the cutting edge, interconnecting the world, electrical engineering's for you. So let's look at some of our past graduates and what they've been doing. These are some of the jobs they've got. These are some of the parts of the world they've got jobs in. Not all, but there's just some examples here. Here's one of our alumni. His name is Adrian Chiok. He worked in Japan for a while, and he's just recently moved to London. And he's an expert in what's called mixed reality, mixing virtual reality with real images to guide you, like this kind of mapping system here, that sort of thing. So that's one of our very successful graduates. Another couple of successful alumni, Dan Kelly and Andrew Beaumont-Smith, both got in the area of designing chips. Andrew worked for Intel for a while and has now moved to Apple. Dan is at Apple. They're both at Apple now, and designing the chips for the latest iPhones and iPads, etc. Another past graduate we had, his name was Nick, worked for Xbox and was making the controller chips for Xbox as well. So we've had a lot of graduates do interesting work like that. Arguably, one of our most successful graduates is this guy, Neil Westy. He was one of our graduates. He got a job at Bell Labs in America, came back to Australia, started a company making Wi-Fi for laptops, and then he sold his company to Cisco 5 years later for hundreds of millions of dollars. So that is quite a good achievement, and arguably one of our greatest success stories. So what are the available programs we have in electrical and electronic engineering? Well, we have the standard electrical and electronic degree. This is the one that gives you a bit of everything. So that's the safest option to go for if you don't quite know where you're going, and you can always change a bit later. But if you're veering more onto the computing side of things, you can do computing systems. If you're veering more towards the sustainable electricity, you might want electrical and sustainable. And if you know that IT is your thing and communications, then you might want the telecommunications side. Otherwise, just stick with the straight standard electrical and electronic engineering degree. Now, but do you want to supersize that degree? Do you want more? Because, you know, some of you might be a bit like me. Like, for example, me, I actually did more than one thing. I did degrees in both electrical engineering and physics myself because I still loved physics. So I still wanted to do that and electrical engineering. And you can do that too, because we had this whole range of double degrees and combined degrees where you can combine the electrical engineering with some other degree. And I have had students that have gone into the stock market industry that have done the electrical and electronic with finance, for example. And I've had some very good students do our degree together with mathematics and computer science. And it's given them a huge extra breadth, and they've become real experts in their fields. So these are the different combinations you can choose, and you can talk about that with the guys at the booth later if you're interested in any of those things. So for more information, I recommend you visit our departmental website. You visit our booth in this building that I can't pronounce the name of, sorry about that. And in the same building that shall remain nameless, you can have a lab tour and come also to our project exhibition on the 1st of November at 10 a.m. in the same building. And because I can't say the name of the building, this is what it looks like, okay? So you can't miss it. And also, I've been asked to advertise this thing on the 11th of December. Thank you.